Welcome to KDSV Knowledge Studio. Get ready to level up your tech knowledge with easy-to-follow tutorials, smart tips, and powerful tools for success.
Are you a QA engineer learning SQL for test validation, data checks, and debugging? Then this video is for you. Learn top 25 SQL mistakes that QA engineers and testers often make, and learn how to fix them like a professional. Whether you are validating data in QA environments or writing test queries, these tips will help you to write clean, accurate, and efficient SQL. This video is perfect for QA engineers, software testers, estate or freshers, or manual tester who is looking for upskilling to SQL knowledge. If you have not watched my earlier video on top 25 SQL queries for software tester, I highly recommend checking it out before proceeding with this one. That video covers the essential SQL queries every software tester should know, explained with the practical examples and real-world scenarios. It is designed to give you a strong foundation in retrieving and filtering data, skills that will make the concept in today's session much more easier to grasp. By watching it first, you will be already familiar with the key SQL commands and classes. Think of it as the perfect prerequisite. It will save your time, reduce confusion, and help you to maximum value from this video. Also, the link for top 25 SQL queries for software tester is provided in this video's description below. Let's see what are these 25 SQL mistakes. The mistake number 1, missing where clause. If you are running update or delete query but you forgot to put the where condition, then what happens? This changes going to apply for all the rows in that particular data table. If you are deleting, then every row is in that table got deleted. Or if you are trying to change, all the rows will get affected. This is one of the most dangerous mistake in SQL. For example, if you put delete from users, then all the data from users tables will be wiped off. Instead, always double check your query using the where condition. I would strongly recommend that, in place of deleting from them, use the select statement and use the where condition and look at the data which is going to be affected. Maybe it's going to deleted or it's maybe going to change or updating some columns. You are comfortable with those select list, then you perform the delete action with the similar where condition. Mistake number 2, using select star instead of specifying the column. It is a very quick and easy steps, but it is a trap. Select star fetches all the columns, even the columns which you do not need. That means it slows the queries, extra data is getting loaded, and fragile test scripts that break when the schema changes. Instead of always specify the exact column what you required for your test scenarios. For example, select ID, name, email from users. This makes your test faster, cleaner, and feature-proof. If the table grows or new columns get added, select star could return unexpected data and will mess up your validation. Mistake number 3, not handling null values. Null means unknown or missing, and comparing it like a regular values leads to surprises. For example, where status equal to null, this won't return anything. The correct way is we have to use where status is null. Similarly, use is not null to exclude the blanks. Also remember, null is not 0 or blank or false. It is undefined. Always treat it with the care. Mistake number 4, using subqueries instead of join. Sometimes testers use a subquery where join would be the more efficient or the other way around. For example, a subquery inside a where clause might work, but it is slower and harder to read. For example, select start from orders where customer ID in, and here is the subqueries where it says select ID from the customer table. A better approach would be use a join. Here is what? Select star from orders, join customers on customer ID equal to CID. As remember, in the earlier mistake, we supposed to not use star. Actually, you need to include the exact column and what you required from each table. It is faster, cleaner, and more scalable. Mistake number 5, incorrect join condition. Ever run a query and get duplicate rows or wrong results? That is often because you are joining tables on the wrong key or forget a join condition altogether. For example, join orders on order.id equal to customer.id. This may work, but logically wrong unless those IDs truly matching. Here, order ID and customer ID, definitely it may not be the same. So we have to use the correct join condition. In order ID, we should look at the customer ID. In the customer table, we need to look at the customer. Always join on foreign key relationships like join orders on orders.customer.id equal to customer.id. This would be the right method. Also double check for missing on class or you will get Cartesian explosion. Use allies to make your join clear and avoid ambiguity in the large queries. Mistake number 6. Not using aggregation functions correctly. Forgetting to add group by or using wrong fields inside the aggregates can totally break your test validation. For example, select department count star from employee. This will throw an error or give incorrect results unless you add a group by department. Also be careful. Column count, count of column ignores nulls, but count star counts all the rows including null. That small difference can cause silent failure in your data checks. Use having clause instead of where when filtering aggregated results, like when checking which departments have more than 10 employees. Mistake number 7. Overlooking data types. SQL does not always throw error. Sometimes it just gives wrong results when you compare incompatible types. For example, comparing number to a string. For example, where user ID equal to in quotes 1, 2, 3. Wherever you put in quotes single quote, that means those values are considered as a string. But user ID is a number column, integer column. So you need to use without the quotes. This kind of mistake might work or might silently fail depending on your database. Always know your schema and match types properly in the filters and joins. A tiny mistake can cause big testing bugs that are hard to trace later. Mistake number 8. Misusing in versus exist. Both work, but they are behave differently, specifically on large data sets. In checks a list of values, but can be slow and memory heavy. Exist is faster when checking for a matching. Exist in a subquery. Slower with the large result sets. Select star from order where customer ID in and using select statement in the subquery. Customer ID from customer tables where status equal to active. Better performance would be use select star from orders where exist in place of using in use exist. Select top one from customer where customer ID equal to customer ID and status is active. As a tester, using the right one makes your queries faster and more accurate. In can be used for small and fixed value list. Exist can be used subquery with the large and complex results. Mistake number 9. Not using alias for readability. Without alias, your queries get messy, specifically when joining multiple tables. For example, select order ID, order.id, customer.name from orders join customers on the customer ID table. Here, wherever you select different column in the select statement, you have to prefix with the orders and customers, the table names. It works, but it is hard to read and maintain for the large set of SQL queries. The better way, you can use the alias for orders table. Here I'm creating alias as a O and customer table I'm creating alias as a C. You can use select O.id and C.name wherever you want to specify the column names. It will be clean, readable and easier to debug. As a tester, clarity matters. Good allies save time and prevent the mistakes. Mistake number 10. Incorrect use of distinct. A lot of testers use select distinct to quickly remove the duplicates, but that is just masking the real issue. For example, select distinct user ID from logins. This might seem fine, but why there are duplicates in the first place? It may be bad join or missing some filters. or we are getting unexpected data. Fix the root cause, but don't just hide using the distinct statement. Use distinct when it truly makes sense, not as a shortcut for messy queries. Mistake 11. Assuming data order without order by. Remember, SQL tables are inherently unordered list. If we do not specify use order by, then result sets can anytime change, even across the environment as well. For example, select start from users. This might look ordered correctly today, but may not be for tomorrow. Always use descending or ascending orders as per your requirement. If you want all the records created recently, if you want these records in the top, use select start from users order by created date. This ensures consistent, testable, and predictable results, which is critical for QA and automation. Mistake number 12. Mixing and or conditions without parentheses. SQL evaluates condition in a specific order, and missing parentheses can completely change your logic. For example, select start from users where role equal to admin or role equal to manager and status equal to active. This actually means admin or manager and active, which is probably not what you want. The correct way is that where your role condition should be in the parenthesis, select role equal to admin or role equal to manager. Then you can perform the AND condition where status equal to active. In this case, either role is admin or manager plus status should be active, then those records will be appear in the your select statement. Logical grouping matters here, specifically in the test validation. Always use the parentheses for clarity and correctness. Mistake number 13. Overusing nested subqueries. Subqueries can solve a problem, but nesting too many subqueries makes your SQL hard to read, hard to debug, and often terrible for the performance. For example, here we have used two level of subqueries, select start from, again select start from sales where amount greater than 1000, and treating the second level subqueries as a new table called high sales. Then I'm performing the one more select start from on top of this. This looks messy, right? Instead, use common table expression, which is called CTE. Here we are going to use specific terms using with. Here I'm declaring with as a high sales. This is the new table, dynamic table name here as select start from sales where amount is greater than. After this common table expression, you can use select start from high sales. So this high sales table is declared within this query statement, and this may not work if you create a new query and try to use high sales. CTE makes complex logic clean and maintainable. As a tester, that means faster fixes and clever validations. Mistake number 14. Not using limit or top. When you explore a table with thousands of records or millions of rows, running a full query can crash your tool, hang your session, or flood your logs. For example, select star from transactions. Instead, start with select star from transaction limit 100 rows. This limit works for MySQL or PostgreSQL databases, and if you're using the SQL Server, you can use select top 100 start from transaction. It will give you only the top 100 records, and if you want to look at top 100 from the latest records, and if your table allows any created date, maybe you can suffix with the order by class and the specific column name and order by descending order, which will give you the top 100 records. Mistake number 15. Confusing between delete, truncate, and drop statements. These comments all remove data, but they are work very differently, and using a wrong one can wipe out your entire test data set from your database. So let's see one by one. Delete. Delete removes the specific row, can be rolled back, and respect the where condition. So in your delete statement, if you have a where condition, it will delete only the matching rows. Truncate deletes all the rows, cannot be rolled back easily, and this is much faster. Truncate should be used only when you want to delete all the rows from the specific table. And if you have some specific condition to delete, then you should use the delete statement. Drop statement destroys the entire table and structure and all of them. So if you want to delete the entire table along with the structure, then use the drop statement. Mistake number 16, forgetting queries or if null in the result comparison. When you're comparing the query results in test, null values can break your validation if not handled properly in your scenario. For example, comparing expected equal to blank versus actual equal to null. They won't match. Here we need to use the functions like queries actual and comma separated with the blank values. Here I'm referring blank as a single quotes, and I'm not giving any blank as a string, just empty. So in this case, if actual is null, queries function will return as a blank. So this one you can use it in the Postgres SQL or SQL Server. Or if null can be used in the MySQL. This ensures your test logic treats missing data the way you intend, not how the SQL interprets it. Always normalize your output using queries when you're comparing the fields. Mistake number 17, using aggregates without the proper grouping. You may use sum, count, or average, but forget to group your data. And that leads to the incomplete or totally wrong results in your query. For example, select department, count star from employees. Here we did not say how to group it. This throws an error, or worst case, it silently ignores the logic. We need to fix this by grouping. Select department, count star from employees, group by department. So in this case, aggregates need the context, and the context comes from the group by classes. Without it, your validation might pass, but on bad data as well. Always ask what I'm going to count or summing up, and group by what. This habit avoids messy test bugs. Mistake number 18, missing between. Many testers assumes between is exclusive, but it is actually inclusive of both boundary values. For example, where amount between 100 and 500. This will return 100, 500 and everything in between. And it is not just the middle range between the 100 and 500. Always check whether including the endpoints is what you want. If you need an exclusive range, use where amount greater than 100 and amount less than 500 in place of using the between. This tiny detail can make the big difference in your test validation. Inclusive versus exclusive range error are stubble, but they are break automated test easily. So you need to know your boundaries as well. Mistake number 19, overusing union instead of union all. Here is the difference. Union removes the duplicate, which sounds helpful, but it adds the extra sorting and the comparison, and this will slow down your query execution. Union all just combines the results without removing the duplicates, and it's much faster. Use union only when you truly need to eliminate the duplicates. Example, select ID from table 1, union all, select ID from table 2. This is perfect when you are merging data source and expect repeats, like test logs or audit tables. Mistake number 20, not backing up before destructive command. Commands like delete, truncate, drop are powerful, but one wrong line can wipe out your data. And guess what? There is no undo button in most database. Always back up your data before deleting the large chunks, truncating the tables, or dropping test data structures. Even in QA environments, lost test data equal to wasted the hours from the QA resource. Be safe, backup first, then clean later. Test environments need just as much protection as a production, specifically when validating the real workflows. Mistake number 21, using count column without checking for nulls. Many testers assume count column counts all the row, but it does not. It skips any row where the column value is null. For example, count star counts all the rows, select count email, skips the rows where email ID is null. So if you are validating data presence using the count email, might give you the false sense of the completeness. Always choose right form. Use count star to count all the rows and use count column and name when you specifically want to non-null values for your test scenario. Nulls are not counted, and if you don't account for that, your test might pass while your data is missing. Mistake number 22, filtering on aggregated values without having. Where filters rows before aggregation, but when you are working with the functions like count or sum, you need to filter after grouping, and that's what having is for. Select product ID count star from orders where count star is greater than 5. This is actually wrong. This won't even run. The correct way, select product ID count star from orders and group by product ID, and you can add the having count star greater than 5. So in this case it will group by product ID and the count of product ID greater than 5, then it will list out the rows. Having lets you filter aggregated results essential for QA validation that look for the thresholds. Mistake number 23, forgetting to handle nulls in sum or average function. Nulls is not 0, it is nothing, and SQL will skip them. That means sum null 50 returns 50, not 50 plus 0. So if you don't handle nulls, you might get incomplete or misleading totals in some cases. Fix it with collies. Select sum collies amount comma 0. In this case, collies function will return 0 if amount is null. This treats missing amount as a 0 and your math finally makes sense. Always sanitize your data before aggregating, specifically in financial or test validation queries. Mistake number 24, using aliases that class with the SQL keywords. Aliases can help you in making your queries readable, but using names like select, from, order can confuse the SQL parsers or trip up anyone reading your code. Bad example. Select o.id as a order and c.name as a form. Here we should not use as a from, because from is one of the SQL keyword. This might work in some database, but it's risky, unclear, and maintenance will be nightmare. The better one, select OID as a order ID, CNAME as a source name. Use alias that are clear, descriptive, and avoid reserved words. It makes your queries more stable and your team happier. If your alias highlights like SQL keywords, it's probably a bad idea. Mistake number 25, forgetting else in the case statement. Without an else, any unmatched conditions returns null value, and that can silently break your reports or test validation. For example, case when score is greater than 90, then A, and we are ending them. Here we are not telling if score is equal to 90 or less than 90, what should be done. So in those conditions, it will return as a null. If the same here, if score is 85, this will return null and it won't be helpful for us. The better way, case when score is greater than, then give result as a. In else cases, print as a unknown value. The else ensures a safe default, so no records goes unclassified. Missing else often leads to hidden null values as well. Thanks for watching top 25 SQL mistakes beginners always make. If you found this video helpful, don't forget to hit that subscribe button so you never miss future SQL tips and tutorials. Share your thoughts and any SQL mistake you have encountered in the comments. I love to hear from you. And if you think that this can help someone else, please share it with them. Until next time, keep learning and keep coding. Thank you so much.